So in the last video, I showed you how to use the array method reduce to sum up a bunch of different numbers or to make a count of different values within an array. But the accumulator in the reducer function doesn't necessarily need to be building up any kind of value. You can also use the reducer function to search an array for the most suitable value for whatever it is you're looking for. So for example, I have here the lyrics to one of my favorite songs by Misery Signals. And down here, I'm using a regular expression to make an array that contains each word of this song. So I want to use reduce to find the longest word here. So before I jump into this particular example, I want to do something similar with a wallet again. So here I have an array that represents a wallet, and inside of this wallet we have a bunch of bills. And I want to use reduce to find which bill is the biggest. So before I write any code, I just want to model how we can think about this just with our brains. So we open up the wallet, the first bill is a 2. And since we haven't seen any other bills, 2 is automatically our biggest bill. So this will start as our accumulator. We move on to the next bill, that's a 1. 2 is bigger, so we just hold on to that 2. The next bill is a 10. 10 is bigger than 2, so we get rid of that 2, and now we're holding on to the 10. This is our accumulator now. The next bill is a 5. 10 is bigger than 5, so we keep holding on to the 10. 10 is also bigger than 1, so we still keep hold of that 10. The next bill is a 20, so this is bigger than 10. So now we get rid of that 10, and now we're holding on to 20. This is our accumulator now. So we move on to 1, 20 is bigger than 1. We move on to 10, 20 is still bigger than 10. So 20 is ultimately what will get returned out of this reducer function and assigned to whatever variable we're using to hold it, because there are no more values in this array. If we were to have, say, 100, and we use this as our initial value, we would start there and look over everything in the array. And I don't need to tell you that nothing in there is bigger than 100. We just went through it. But JavaScript is a single-threaded language. It can only look at things one at a time. It can't just tell that nothing's bigger. So it would have to go through that same process again and realize that there is nothing larger. So how I would do this using reduce is I would create a constant called largest bill, and I would assign that the value of calling reduce on wallet and passing in this callback function here. And I'm going to call our accumulator largest for now, and the current will just be current. So what I'll have to do is check if the current is bigger than the largest. If it is bigger than the largest, then I will return that. And if largest is, the largest, then I'll just return what we've already been holding on to. So all I can say is just return and check if the current is greater than the largest. If it is, I'll return current. Otherwise, I will return largest and nothing will change. So if I see what largest bill is, we get 20. So if I pass in this larger bill as my initial value, we get 100. Makes sense. So I'm just going to place a couple more of those strategic console log statements in here and see what happens. Shouldn't have changed the names here. So I'm just going to print this out to the console so we can see it a little easier. So in this case, I'm going to get rid of the initial value and try that again. So we start with a 2, we go into the 1, 2 is bigger than 1, so we keep the 2. We go on to the 10, now the 10 is bigger than the 2, so we hold on to that 10. And it is our accumulator until we come across this 20. Then 20 stays the accumulator until we reach the end. Don't find anything bigger than 20. We return that out of reduce and assign it to largest bill. So that's what's going on here. You might notice that we could also use mathmax to do the same thing. And it might even be a little simpler. So we can just say, assign to largest bill the result of calling mathmax on this wallet using spread syntax to just pass everything in as an individual value. And then if we just add in larger bill as another argument, it'll find that as well and say that our largest bill is 100. So this works because these are all numbers, but what if we want to find the largest word in here? We can't just pass in words array because it'll give us not a number, because nothing in there's a number. It's just comparing a bunch of strings, and mathemax doesn't work on strings. So how can we use reduce to find us what the longest word here is? So what we'll do is going to be very similar to what we just did with the numbers, except for instead of comparing the value of the numbers, I'm just going to compare the lengths of these strings and return whichever string has the highest length. So I'm going to create a constant called longest word and assign this the value of calling reduce on words array. So the accumulator, I'm just going to call it longest, and then I'll have the current. And what I'm going to do is check if the length of current is greater than the length of what we have called longest. If it is, just return current. Otherwise, return longest. So let's see what our longest word is. Searching. All right, so that's a solid 9-letter word. It seems pretty reasonable that that could be our longest word. So I'm going to add in a couple more of those strategic console log statements so we can see how these values are changing during every run. Okay, so there's a lot. We start with the word embrace. That's pretty long. We compare it to the word this. Embrace is clearly longer, so we return embrace, and that is what gets assigned to our accumulator or to our longest word. The next word is sickness, so that's longer than embrace. So it looks like sickness is going to stay the longest word for a good while here, but we remember that it eventually gets replaced. But none of these words, see, we find one that looks like it has the same length, but let's see. Yeah, they're the same length, but we only return the current word if it is longer than the longest word. We could switch around the order of things in here to make it so any word we come across that is the equal length will also be returned, but that's not how we've done things here. So yeah, sickness is still our longest word. And here we go. Now our current word is searching. This is 1 letter longer than sickness, and for the rest of the run, for every other time we call this reducer function, searching is going to be our longest word. We reach the end. Nothing has been longer than searching, so this is what we return out of our function and assign to longest word. Now, if I were to pass in, say, anti-disestablishmentarianism as our initial value, nothing is longer than that. No word in these lyrics, no word that is inside of this array is going to replace that. So this is going to stay our longest word until we return and assign it to the value, or assign it to the constant longest word. But finding the longest word isn't tricky enough. So now what I want to do is look through this array and count the number of times each character appears, and then determine which character appears most frequently and which character appears least frequently. These are 2 different tasks, and we can do both of them using reduce. So let's see how we can do that. So for now, I want to just ignore these things. So what I want to do is create an object that has as its properties all of the characters that exist in this string. And the values of those properties will be the number of times that those strings pop up. So I'm going to create a constant called letter count. So what exactly am I going to set this? What am I going to assign to this? So rather than using this words array, I'm just going to set it equal to misery signals lyrics to lowercase, because we want the upper and lowercase versions of each letter to count as single values. And I'm going to split this on an empty character, so that will give us an array that just has character by character every letter inside of these lyrics. So notice that you can only call reduce on an array. This is an array now. But since JavaScript has a lot of different methods that allow you to turn different data types into arrays, it is almost as if I'm calling reduce directly on this string. I just have to do a little bit of work to be able to do that. So now we're ready to pass in our callback function. So I'm going to say counter, because we're counting something this time, and current letter to just be descriptive. So before I deal with our reducer function, I'm going to think about what our initial value is going to be. So we want an object, and when I was doing the odd and even count, I gave it odd and even properties because we knew exactly what we were looking for. In this case, though, I don't want to just hard code in an A property and a B property and a C property and assign those all a value of 0, because that would be inefficient, it would be repetitive, and it's also not even guaranteed that all of the letters in the alphabet are going to appear in these lyrics. So it would be just more work that I need to do. What I'm going to do is I'm going to just add in any character that I come across when I come across it. So the first thing I want to do is check if our counter has the current letter as a property. So if it does not, I'm going to add that property in and assign that 0. And after this, I'm going to just increment that by 1. I should have called this current letter. And we see here that we cannot read the property has own property of undefined, because our counter after we run this once is undefined, and that's because I'm not returning it. JavaScript methods and JavaScript functions automatically return undefined if we don't return anything ourselves. So that's why counter, the second time this reducer function is being called, is undefined. So all I have to do is just say return counter, and these errors will disappear. So let's see what letter count is now. Okay, so it's not even showing us the whole thing because it's quite big. So I'm going to log this to the console and see what it looks like. Okay, so we get this long object. It looks like it's picking up new line characters and apostrophes and spaces as well. So that's what's expected. We don't necessarily want to take those into account when we're looking for our most and least used characters, because it seems like the space is going to be the most used character since there's one between every word. But we can deal with that when we get to it. So just to show you how this object is being built up, I'm just going to do another console log of the counter, and we can see how that grows. And I'm going to get rid of this. So we see the counter just starts as an object that only has an E property because the first letter in these lyrics is an E, comes across the M and adds that on. So the word embrace has 2 E's in it. So rather than adding a new E property, it's just going to change that E. Oh, well, yeah, you see it's a 2. So at some point here, it becomes so big we can't display it on the same line anymore. So yeah, we just see that every time this reducer function gets called, we are adding on further values to this object. It takes quite a lot of space printing out every single iteration of this, but this is how it gets built up. We're returning the same object over and over again, and every time we come across a new character, we either add that as a new property onto this object, or we increment the property if it already exists. So this is how we can use reduce to build up a large data structure like this. But now what we want to do is use reduce to find which letter appears most frequently and which letter appears most frequently. So there are certain characters I don't really care about right now. So I'm gonna just delete spaces. We could have also used filter to do this, but I think it's more efficient just to get rid of it here rather than running a test every time this runs. So I'm just going to get rid of spaces, I'm going to get rid of new lines, and I'm going to get rid of apostrophes because we just want to focus on letters. So how can we use reduce to figure out which letter appears most frequently and which letter appears least frequently? So let's think about the kind of data structure we're working with here. We have this letter count object. All of its keys or properties are the characters we want to look through, and all of the values are the number of times those characters appear. So this is the data we need, but it's an object and we can't use reduce on it or any of the other array methods because we can only use those on arrays. So how can we actually use reduce to solve this problem? Well, it turns out that JavaScript has a couple of built-in methods that allow you to convert the data within an object into an array. So I'm going to create a constant called most and least used letters. It's kind of long, but it is pretty descriptive. And what I'm going to assign to this is object.keys, which is one of JavaScript's methods. And we're going to pass in letter count as an argument. So let's see what this gives us. Okay, so what object keys does is return an array that is just all of the properties that are in an object. We also have object values, which intuitively does something similar, except it gives you an array with all of the values that exist in an object. But something that's probably more useful for what we're doing right now is object entries. And what this does is basically turns the key value pairs within this object into their own subarrays and puts all of those subarrays into one larger array. So as we can see, the first element in each of these subarrays is going to be a key, and the second element in the subarray is going to be the value associated with that key. Now that I've converted this array, or now that I've converted this object into an array, I can use array methods on it. So now I can solve this problem using reduce. So as usual, our callback function is going to have an accumulator. Here I'm going to just call it tracker because I'm going to be tracking multiple values, and current. Oh. Well, since this is a subarray and every time we're going to be passing in an array with two values, what I want to do is use destructuring assignment. So we're going to have current letter and current count. So that might be a little confusing right now, but it'll make sense once I start writing the callback function. So for now, I just want to say return tracker. So as we know, since we haven't passed in an initial value, that's just going to be the first thing in our array. So this is the first key value pair that is in this object, or the first subarray that is in our the array we created using object entries. This isn't really what we want though. We want to keep track of the most used letter, the number of times that appears, and then the least used letter and the number of times that appears. So we want to keep track of 4 different things here. So we have to think about what sort of data structure we want to use to do this work for us. So I'm going to pass in an empty object for now as our initial value. So what do we want to put on it? I want to give it a property called most used, and I'm going to give that an object. And I'm also going to give it a property of least used, and I'm going to also give that an object. So each of these are going to have a letter property and a count property. So for now, I'm just going to make these match up with the first thing in our array. And if something is more suitable, it'll just replace that. I think it's usually not the best choice to just hard code data in like this, but this video is getting sort of long, so I just want to solve the problem in a somewhat straightforward way. So I'm just going to say letter, give that an E, and then count and say 56. And if we find something that's used more than 56 times, we want to replace the most used letter and the count. And if we find something that's used less than 56 times, we are going to change the letter and the count here as well. So that's actually pretty straightforward, even though we're working with a kind of large amount of data. So what I want to do first is check if the current count is greater than tracker.mostUsed.count. So since this is our initial value, this is what's getting assigned to tracker. So tracker has this most used property, and the most used property, which is an object itself, has a count property. So if we find something that has a higher count, all we want to do is just replace those properties. So tracker.mostUsed.letter is going to be assigned the current letter, and the count will be replaced by the current count. And we want to do the same thing or something similar if we find something that is used least frequently than the least used character. So here I just want to say if the current count is less than the tracker's least used objects count property, I'm going to replace that, the letter there, with the current letter. And I'm going to replace that count with the current count. This is kind of messy and repetitive. Oh, what am I doing wrong here? Cannot set property count of undefined. Least used is not spelled correctly. Okay, so this should be working now. Like I was saying, this is kind of repetitive, and it's usually not the best choice to be repetitive. I'm just trying to write this in a way that will be clear if you're not entirely certain on how reduce is meant to be used. And if you don't understand what destructuring assignment is here, I could have just passed in something called array, and rather than saying current letter, I could have said array bracket 0, and instead of saying current count, I could have just said array bracket 1. But in this case, I think using destructuring assignment is significantly clearer, because since we know we have an array that has 2 elements in it, writing a parameter that looks like this will just take the first thing in the array and assign it to this variable current letter, and it'll take the second thing in the array and assign it to current count. So I can just cleanly refer to these things here instead of having to just say array bracket 1 or something like that. So now that we've done this, we should have our results. So we can see here, most used, the letter is E and the count is 56. So that didn't change. The least used, the letter is X and the count is 1. And I think that makes sense because E is a pretty prominent letter in the alphabet, whereas X isn't used so often. Even though this is kind of a tricky and ugly data structure, we did effectively use reduce to keep track of 4 different pieces of data. If we wanted to do this in a more clean way, we could have used destructuring assignment here as well. So I'm going to comment this out, and instead of having most and least used letters, I'm going to have most used and least used, and this should give us 2 different variables. So if I look at most used, this is just an object that shows me the most used letter and the number of times that's used, and least used, that is now an object that shows me the letter that is used least frequently and the number of times that's used. So I can just say most used.letter, most used.count to access those properties, least used.letter, and least used.count to access those properties. But this video is about reduce, not destructuring assignment, so I would recommend looking into that topic somewhere else. In the next video, I'm going to show off a couple more things about the reduce function that I haven't worked with yet. And then after that, I'm going to implement it. I'm going to write code that makes a working reduce function so you can really just see how it works under the hood.